Hello everyone, my name is Samuel Silvasiran. I am from third year mechanical department, and in this module we are going to discuss about what is meant by chemical machining and its principle and working procedures and applications. And before going into the topic, we need to know what is meant by machining. It is somewhat a metal removal process which is used to remove the material from the workpiece to obtain its desired shape and size. It is the most expensive and more power consumable process in the manufacturing sector. And the machining process is classified into two types of conventional and non-conventional machining process. In the conventional machining process, mechanical energy is used to remove the material from the workpiece, but in the non-conventional machining process, other sources, somewhat electrical and lasers and chemical, which chemical solutions which are used to handle the machining process. And here comes chemical machining. And it is a process which is used to dissolve the workpiece material in the chemical solutions. And we have been familiar with the term machining, so it is very easy to understand this term too. In chemical machining process, we are using the alkaline solutions or the acids to remove the material from the workpiece. It is the starting stage for the modern machining process. So before going into the working procedure, we need to be familiar with the two terms, mask and etching processes. It is mask. You may all wonder how it can be possible if the workpiece is then immersed in that solution. The total workpiece per chance can able to has the opportunities to dissolve into that solution. So how we can able to resist that? That is why the term mask is introduced. This is the photoresistive layer which is applied on that workpiece, which is somewhat very resistive to the etchant solution. So the material below that which can't be removed from that alkaline solution or the acidic solutions. And etching process, it is the most important process in the chemical machining because it decides the rate how the rate at which the material needed to be removed. So we need to be more familiar with this term and have a look at this diagram. Here the mask has been coated here, and there is some workpiece removed under the mask layer also, because the alkaline solution removes the workpiece here and then comes and perchance have the opportunities to clear the material from this too. So there is this is called depth of cut, the height in which the material has been removed, and under the mask layer some material is removed. This width is known as the undercut. So the here is a term introduced, H factor, which is equal to undercut divided by the depth of cut, which is the most important term while deciding the mask material. And let us move on into the working procedure. First of all, the workpiece needed to be thoroughly cleaned, and secondly, the mask and the etchant layer is then chosen. Both needed to be resistive to each other, and then the mask layer is applied on that workpiece, and then it is then dipped into the alkaline solutions. The acidic solutions. Then the material is removed where the masking layer is not applied. There are some of the limitations we can able to see. Sometimes the solution may be deactivated by the excessive observation of a workpiece. So then the solution needed to be introduced newly to activate the chemical machining process. And sometimes there is a chance of here we need to uniformly cut a 10 mm from all the sides, but somewhere the alkaline solutions or acidic solution, which is somewhat more reactive, and somewhere it is not much reactive. So the depth of cut may be vary side to side. So to continuously remove the workpiece material in a constant way, then the solution needed to be stirred so that the material can be removed from all the direction in an even manner. So, yes, that's all the working procedure we needed to know. But preparing the mask, we need to study this in an elaborated way. First of all, a design needed to be created 2 to 20 times maybe larger than the actual design, then that is how we can able to increase the efficiency. And then the next step is then the desired pattern is then shortened to the actual workpiece size than the pattern which is called as a master transparency pattern. And this why this master transparency pattern is then coated on the material, because this helps us to coat the mask on that workpiece. Then it is the pattern is then coated. Then it is coated with the photoresist material and then baked dye. So the total workpiece is then covered with that covered with that layer. Then the workpiece is then exposed with that ultraviolet light, so that we can able to remove the layer, masking layer from where are all the etchant solution which we decide needed to be applied. So this is how the masking layer comes to an end. And have a look at this diagram. This is the workpiece, and the photoresistive coating is then mask is then coated, and then it is then removed, and the etchant solution is applied, and then it helps us to remove the material, and then the mask is removed. This is the final desired workpiece. And there are some criteria which under which the masking material needed to be selected. It is needed to be chemically resistive, which should be resistant to the etchant solution, and for a longer time duration also needed to be evaluated for that, so that the depth of cut can be considered. So, and the quantity of parts, we can't able to get accurate measurements for all the processes. If it is in mass production, we need to go with an economical way. So sometimes we need to remove all those things and go for some economical way also. And ease of removal, then the mask layer is then coated, and it needed to be removed from the workpiece, so that we can able to uh, fetch and remove the workpiece with the help of agent solution. And these are all the criteria which helps us to select the masking material. And there are the three ways of masking the making the mask. The first method, cut and peel, and the second method, screen printing, and the third method, photoresist mask. First of all, let us discuss about a cut and peel. Cut and peel method, generally an European or butyryl or vinyl based thick material which is applied by dip, spraying, or flow coating. This is a more accurate. If we needed to get the workpiece in a more accurate way, we need to go with this method, because it's the masking thickness are also 0.025 to 0.125, so that the higher depth of cut can be obtained, which helps us to get the workpiece in a more desired and more accurate way also. And but it is somewhat expensive. That is also needed to be considered. And here comes screen printing. It is not at all an accurate procedure which is needed to be followed, because it is a more economical process, and then accuracy is not at all maintained here, because the thickness of the mask is also always less than 0.05 mm. So for the mass production, it can be very helpful, which is mostly used nowadays. And a photoresist mask, and this is the diagram which I have mentioned above, which is actually photoresist masking, because the photoresist coating is then applied above, and then the negative master pattern is then applied, and then it is exposed to environment, and then it is removed, and then the solution is, helps us to remove the workpiece. And I actually placed this image for the better understanding of the masking, so please don't mind of that. And then the etchant solution. the same way, there are criteria for selecting the masking material. So the same way, we need to consider how we need to select the etchant solution also. Surface finish. The etchant solution needed to be well precise that it can't be easily converted to oxides because it can able to affect the outermost surface by some crack or little bit of holes. And the removal rate yeah, it needed to give us the perfect surface finish, and the rate of removal is also an criteria which we needed to select and etchant solution. And then at last, the material type. Here there are numerous factors which can able to affect the material, intergranula attack, hydrogen embrittlement, or surface corrosion cracking. All these processes are there, so we need to be precise and how to choose the masking material and the etchant solution according to the material too. And some etchants generally used are iron chlorine, chromic acid, hydrofluoric acid, and nitric acid. These are the most commonly used etchant solution. And then we came at last to applications. What are all the applications we just needed? And chemical machining is somewhat used in an to obtain the product in a more accurate way. Then the chemical machining can be used. Small size of a product can also be produced by this process, and it can be able to remove any kind of a material. So it is an it can well go with this process compared to many other mechanical machining process also. And in aerospace also there is a wide range of applications for chemical machining. And these are all the books I have referred. Mostly, I referred from P. and Rao Manufacturing Technology. And if chance you are not good with the explanation, have a check on that. And we need to have some visualization so that we can able to better understanding of this concept. So let me have a look at the animation video of how the chemical machining process is maintained. That's all I have for today. We have been discussed what is meant by machining and then chemical machining and its working procedures and how the mask is prepared and etchants, how we need to select the etchant solution and how we can be able to select masking material, what are its criteria, and finally we have discussed what are its applications. So hope you guys have a better knowledge on this subject. So thank you for giving me this opportunity to share my knowledge with you. Thank you.